The next type of probability distribution is the hypergeometric distribution. The hypergeometric distribution is associated to a hypergeometric random variable which is defined from a hypergeometric experiment. A hypergeometric experiment involves selection of objects from a population of objects without replacement. So in this case, we shall select small n items from a population with capital N items. So in this figure, this is our population that contains the capital N items. Now, these capital N items are classified as either a success item or a failure item. The number of success items from these capital N items is K, and the number of failure items will be capital N minus K. So this group here is composed of the success items, and the other group will be composed of the failure items. So in a hypergeometric experiment, we are supposed to select small n items from capital N items. And the random variable x, or the hypergeometric random variable, is defined as the number of success items in the selection. So we're going to count the number of success items from this sample of small n items. So we have to place x here. And if x success items are selected, then the number of failure items that will be selected is small n minus x. So in the formula of the hypergeometric distribution, combinations shall be used because we are selecting objects without replacement. So the formula here is P of x equals k combination x multiplied to capital N minus k combination small n minus x divided by the total number of outcomes of the experiment, which is capital N combination n. Now, the lowest possible value of x in a hypergeometric distribution is the maximum between 0 and small n plus k minus capital N, while the highest possible value of the hypergeometric random variable x is the minimum between small n and k. Now, similar to the binomial distribution, we can also compute the mean and the variance of the hypergeometric random variable, and the formulas are given as follows. So the mathematical expectation, or the mean of the hypergeometric random variable x, is small n times k over capital N, while the variance is given by this formula. So it is capital N minus small n divided by capital N minus 1 multiplied to small n, multiplied to k over small n, and multiplied to 1 minus k over, uh, sorry, this should be capital N. So k over capital N multiplied to 1 minus k over capital N. Now, the standard deviation can be obtained by getting the square root of the variance. So let's have an example. A committee of size 5 is to be selected at random from 3 women and 5 men. What is the probability that the committee will contain 3 women? Let us define the random variable x. So in this particular item, we're counting the number of women in the selection of 5 people. So in this experiment, we are supposed to select 5 people out of from the 8 people available. So in this case, we have a population of n items, and the success items would be the women, and the failure items are the men. So in this case, the number of women is 3, so k equals 3, and the number of men is capital N minus k equals 5. And then we are supposed to select small n items from this population, and that small n is equal to 5. So our random variable x is the number of women in the selection. So x will be placed here, and then the number of men in the selection will be 5 minus x. So in letter A, we want to find out the probability that the committee will contain exactly 3 women. So in this case, we're going to get the probability that x is equal to 3, which is equal to small p of 3. And according from the formula of the hypergeometric distribution, this will be 3 combination 3, and then we have 5 combination 2 divided by 8 combination 5. And this is equal to 0.1786. Okay, so if our random variable x is the number of women in this selection, then the lowest possible value of x will be the maximum between 0 and n plus k minus capital N. And the lowest and the highest possible value of x will be the minimum between n and small k. So in this case, we have the maximum between 0 and we have small n as 5 plus k is equal to 3 minus 8, which is the population size. So 5 plus 3 is 8 minus 8 is 0. And then we have the minimum between small n, which is 5, and k is the number of women, which is 3. So in this case, the values of x would run from 0 up to the minimum between 5 and 3, which is 3. Now this is obvious, no, because the number of women from the population is 3, so which means it cannot exceed the value of 3. So there can't be 4 women in this election because the maximum number of women in the population is 3. For letter B, this time we want to know the probability that the committee will contain at least 4 men. And let us define the random variable x. So in this case, the random variable x is defined as the number of men in the selection. So in this case, again, we have a population of n items or 8 items, and then the success items will be the men and the failure items will be the women. So if the men are the success items, then k is equal to 5, and the number of women in the population, which is capital N minus k, is 3. And then we are supposed to select small n items, which is 5. So therefore, the random variable x would run from the maximum between 0 and n plus k minus capital N up to the minimum between n and k. So the maximum between 0 and another quantity, so yung n plus k minus n, we have 5 plus 5 is 10 minus 8, which is 2. And then we're going to get the minimum between n and k, or small n and k, that's 5 and 5. So which means the number of men will run from 2, because the maximum between 0 and 2 is 2, up to the minimum between 5 and 5, which is 5. So x will start from 2 and ends at 5. So in this case, x cannot be 1, because if the number of men is 1, that means we're supposed to get 4 women, but there are only 3 women in the population. So that's why the lowest possible number of men in the selection must be 2, and the highest possible number of men in the selection must be 5. So if we want to get the probability that the committee will contain at least 4 men, that means we're going to get the probability that x is greater than or equal to 4, which is p of 4 plus p of 5. And the probability that x equals 4 would be 5 combination 4 multiplied to 3 combination 1 divided by 8 combination 5 plus 5 combination 5 times 3 combination 0 divided by 8 combination 5. So this sum is the probability that the committee will contain at least 4 men. And this is equal to 0.2857. Okay, now for the third item in this situation, we're supposed to find the mean and the variance of the random variable x that represents the number of men in the selection. So if we're using the random variable x as the number of men, then small k must be 5, and then we have small n as 5. That's the number of samples we're supposed to get from the population items of 8. Okay, and then the mean or the expected value of x is given by the formula small n times k over capital N, which is 5 times 5 over capital N is 8. So this is 25 over 8. And then for the variance, now the formula is quite long. This is capital N minus small n over capital N minus 1 times small n times k over capital N times 1 minus k over capital N. So the variance will be capital N minus small n is 3, and then over capital N minus 1 is 7, multiplied to n equals 5, and then multiplied to k over capital N, which is 5 over 8, and then multiplied to 1 minus k over capital N, which is 3 over 8. So using your calculators, just compute this variance quantity. Now, to get the standard deviation, of course, you know that you're supposed to get the square root of the variance. Okay, now for another example, if 5 cards are dealt from a standard deck of 52 playing cards, what is the probability that 3 of the selected cards will be hearts? So in this scenario, we are defining x as the hypergeometric random variable that represents the number of hearts in the selection. So our population items would be the 52 playing cards, and we're supposed to identify the items as success items and failure items. The success items are the heart cards, and the failure items will be the other cards. Now, the number of heart cards from the standard deck is k equals 13, while the number of other cards is equal to 39. And in this experiment, we are supposed to select 5 cards without replacement. So we're going to place x here, and then here we have 5 minus x. So for our item A, we're supposed to get the probability that there will be exactly 3 hearts in the selection. So that's the probability that x equals 3 equals p of 3, which is given by the formula 13 combination 3. Okay, so we're going to substitute 3 in this x here. So 13 combination 3 multiplied to 39 combination 5 minus 3, which is 2. Oops, there's no over here. So this should be 39 combination 2 over 52 combination 5. And using your calculators, you'll find out that this is 0.0815. Now for letter D, for the mean and variance, so the mean is mu sub x equals small n times k over capital N. So since we're selecting 5 cards, that's small n, and then k is the number of hearts in the population items, so that's 5 times 13 over capital N, which is 52. So this gives us 65 over 52. Now for the variance, now using the formula of the variance, we have capital N minus small n, which is 47, over capital N minus 1, which is 51, times small n, which is 5, multiplied to k over capital N, which is 13 over 52, and then multiplied to 1 minus 13 over 52, which is 39 over 52. So again, just use your calculators to get the exact value of this product. Now, for the standard deviation, of course, you will need to get the square root of the variance. Okay, so that ends our discussion of the hypergeometric distribution. And then the next video will focus on the next type of probability distribution, which is called the Poisson distribution.